Why can a ship's diesel engine run day and night for months without taking a break? Because marine diesels are built for one job: steady, efficient power at low stress. Think of it like this: a car engine sprints and stops all day. A ship engine is a marathon runner that keeps a calm pace, hour after hour, built to survive the distance. First, speed. Many of the biggest marine diesels turn surprisingly slowly, often around 10s to a little over 100 RPM, not thousands like a car. Lower RPM means fewer cycles per minute, less friction heat, and less mechanical fatigue. When parts aren't being whipped back and forth, they last longer. Simple physics, huge payoff. Second, efficiency. Diesel engines squeeze more work out of fuel because they run with high compression and leaner mixtures. And ships love steady loads. The propeller is basically a constant demand machine. That steadiness lets the engine stay near its sweet spot, where fuel becomes motion with less waste heat. Third, mass and strength. A marine diesel is less like an engine and more like a power station bolted to the ship. Big components don't just look impressive, they reduce stress. Larger bearing surfaces spread loads. Thick structures resist flexing. Less flex means better alignment, better sealing, and fewer surprises over time. Now reliability is mostly about one unsexy word: lubrication. Ships keep a continuous river of oil moving through critical surfaces, carrying heat away, preventing metal-to-metal contact, and trapping contaminants in filtration systems. If you control friction, you control wear. If you control wear, you buy months of runtime. Next is cooling, and the goal is not cold. The goal is stable. Marine engines manage temperature like a thermostat for a city. Keep it in the safe zone, avoid hot spots, avoid thermal shock. Stable temperature means stable clearances, stable lubrication, stable combustion, and that stability is what makes months realistic. Ships also treat fuel like a process, not a gamble. Heavy fuel can carry water and particles, so ships rely on cleaning and separation systems to reduce what the engine has to swallow. Cleaner fuel means cleaner combustion. Cleaner combustion means fewer deposits, fewer stuck rings, and fewer power losses over long voyages. Here's a huge one: redundancy. Marine systems assume something will eventually fail, so they're designed so a single failure doesn't end the trip. Multiple pumps, parallel filters, backup power, alarms, monitoring, layers that keep the engine in a safe operating window even when components age. And modern ships don't wait for a bang. They watch the engine's health constantly: pressure, temperature, vibration, oil condition. Most big failures start as small signals. If you detect the signal early, the engine can keep running safely instead of becoming a headline. So marine diesels last for months because they're slow, efficient, massively overbuilt, carefully cooled and lubricated, and protected by redundancy and monitoring. Now your turn. What do you think is the biggest reason? Low RPM, heavy-duty design, or smart monitoring? And what everyday machine would you want built to ship engine standards?